Okay, so welcome to Calculus 1. For the purposes of the class, you're going to be getting lessons via YouTube that I make using what you see here, OneNote. You will be getting a lesson for each individual section in the textbook. I create lesson handout packets that we can follow through to make the process much easier and more organized. So you will see that all through my YouTube channel for Calculus 1. But before we even get to that, it is vital that you know certain trig concepts in order to even start Calculus 1. So since this is a summer course and I have no idea where a lot of the students are coming from, a lot of visiting students. I'm going to make sure that you know the very basics of trig and what you need to know for the class. Okay, so the first concept is just pure trig evaluation. So for example, if I asked you for the sine of 3 pi over 4, could you do that right now? So you ask yourself, and this is no judgment, but could you literally just come up with that out of thin air? The reality is, if you are in calculus, then you should be able to do that. So some of you are going to be like, oh, that's no problem. Others are going to be like, oh boy, I don't think I can do that. Well, that's what this entire lesson here is about. It's making sure that you can get to the point where you can do that. I'm not going to do a ton of problems, but I want to make sure that all is good with that. So how do we start? Well, we start with the important concepts in terms of what we're going to talk about. So remember, we usually use theta to represent the angle of importance, right? The rotation that we have. And just remember that in any type of, let's say if we just talk about, we'll go strictly to the unit circle, and we go, well, we start always on the positive side of the x-axis and we rotate to whatever angle or rotation we want. So that would be our angle theta that we are our own importance. And we are always going to be talking about, I know a lot of you are going to be used to degrees, but we are not going to be doing degrees in this class either. It's all about radians. So you got to make sure that that is a key component of this. So what are the important formulas that you need to know? First one, in a unit circle, if you take the sine of theta, it is always going to be equal to y, as in the y coordinate of your rotation. Cosine of theta is always going to be equal to the x coordinate of your rotation. And the tangent of theta is always going to be equal to y over x. Okay, so what does that mean exactly? So you're going to rotate to a certain radian value, and then on the unit circle there's going to be a coordinate. That coordinate is x comma y, and these variables right here, these formulas, are utilizing these variables to figure that out. Now remember, we also have the reciprocal trig functions. You only have to memorize these because you should know that the reciprocal trig function of cosecant theta for sine, we got secant theta for cosine, and cotangent theta for tangent. But what does that mean? That basically means you're going to invert whatever the formula is. But in reality, all you have to do is know these three, because if you know these three, then you just invert them to find their reciprocal buddies, which are over here. Okay, so that's the first part of importance, is knowing these formulas. Okay, so we'll just call this Roman numeral 1. Okay, so what's the second part? We'll go over here, Roman numeral 2. You also have to know special coordinates. For example, we know that pi over 6 is, by the way, a 30-degree angle. Now, degrees aren't going to even come into play with what we're doing. We're all going to be talking about radians, but it is a 30-degree angle, and pi over 6 always occurs at the coordinate root 3 over 2, 1/2. This is something that you should already know and should be memorized. Pi over 4, which is a 45-degree angle, is always going to occur at root 2 over 2, root 2 over 2, and pi over 3, which is our 60-degree angle, is going to occur at 1/2 root 3 over 2, which is the opposite of our pi over 6 angle, or a swap of the coordinates. So basically, these are the first two important pieces of information that must be known. Now, there are some other interesting side products to that. So in a unit circle itself, we also have standard rotations. For example, this is going to be at 0 rotation. This is going to be at pi over 2. This is going to be at pi, and this is going to be 3 pi over 2. At those rotations, we also have coordinates on the unit circle. We have 1, 0. We have 0, 1. We have -1, 0. And we have 0, -1. These will come in handy. And note, 0 is the same as 2 pi as well. If you want to make a sort of a mental note of that, that'll also be the case. But these coordinates do come into play often with other things, so I'm just including them, but note that they are going to be of importance for what you're doing here. Okay, so last major concept has to do with quadrants. So what does that mean exactly? So in the unit circle, we basically have a nice little fancy saying that we can use to determine the sign of trig functions in each quadrant. So just remember that we are dealing with, let's say, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, and in those quadrants, it is important that you know the following. All students take calculus. Okay, so if you remember that sentence, usually makes life a little bit easier for remembering how this works out. So all students take calculus, and you have to follow the the quadrants all the way around in a counterclockwise rotation. So starting over here. So what does that mean exactly? So if you are analyzing, evaluating, whatever you want to say, if you're evaluating a trig function in the first quadrant, it is always going to be positive. If you're evaluating a trig function in the second quadrant, if it's sine, it will be positive. If it is tangent or cosine, it will be negative. Now, just a small side sort of to that is that this also applies to the reciprocal function. So if when I say the sine is positive, then of course the cosecant is as well, and all the other ones are not. So I don't really go into that, but just realize that that also means that. So if I go over to the third quadrant, then only tangent is positive, and its buddy cotangent. And that means sine and cosine are negative. And lastly, if I go to the fourth quadrant, only cosine is negative, and its buddy secant, and all others are negative. Okay, so if you look at all three Roman numerals here, these are the major concepts in trig evaluation. So what we're going to do next is we're going to go through just a brief few examples to talk about how we would find the trig evaluation for any trig function that I give you at a certain radian value. That's going to be the main focus of what we're going to be talking about in the beginning here for our trig review. Okay, so let's go back to that problem that I was talking about in the beginning, sine of 3 pi over 4. Okay, so how exactly would we do this problem or evaluate this without using a calculator? Because you won't have a calculator to do this on an exam. So this is something that needs to be literally like that. You need to be able to just immediately find what this is. And no, you do not want to convert this to degrees. That's not the way to do it. If you're taking calc, if you're going further, you should not be using degrees as a crutch. Radians is what's important. So the first thing you want to do is you want to determine where 3 pi over 4 is. Okay, so 3 pi over 4, the best way I sort of show students to really understand this is think of this as use our basic values. So we know this is 0, we know this is pi, right? But if we wanted a common denominator of 4, then what pi over 4 is equal to pi? Well, that would be 4 pi over 4, which would be over here. So obviously 4 over 4 is 1, which is pi. So that means we would have to go back a pi over 4 into this quadrant to get to 3 pi over 4. So basically we are in the second quadrant. That'll come up in a second as something that's important, but we need to know where it is. So what is our first step? Well, we kind of ignore 3 pi over 4 and we think about what the reference angle is going to be. And the reference angle is actually this guy over here. The reference angle of anything pi over 4 of relevance is just going to be pi over 4. So we go back to its basic family member and we go, well, what's the coordinate of pi over 4? It is root 2 over 2, root 2 over 2. Okay, so what is the sign of the reference angle pi over 4? Well, the sign of pi over 4 is going to be the y coordinate. Well, that is this, which means it's root 2 over 2. Okay, so we have found that the sign of pi over 4 is root 2 over 2. Now we have to figure out what the sign of 3 pi over 4 is. How do we do that? Well, the answer is either going to be positive root 2 over 2 or negative root 2 over 2. How do we determine which one it is? We simply use all students take calculus. So we go over here and go, this is the important quadrant. According to this, we are in quadrant 2 where sign is always positive, which means the sign of root 3 pi over 4 is root 2 over 2. Now this took like, what is it, 30, 45 seconds to do, but in reality, it wouldn't take that long if you were just doing a basic evaluation and you got the hang of this. That's the way to do it. Now, just as a side note, there are also students that memorize each one of the coordinates in each quadrant. If you know that by heart, feel free to do that. It's just, I don't ask students to memorize all the coordinates in a unit circle, nor do I sort of pinpoint what the coordinate is in that quadrant. You can do that if you like. That's not an issue. I tend to just stick to reference angles because it makes it much, to me, a much easier flow through the information. Okay, let's try another one. So let's say if we did the cosine of 7 pi over 6. All right. All right, here we go again. We go to our unit circle and we want to find out where is 7 pi over 6. Well, remember, as I said before, this is pi over here. So if I need a common denominator to make this equivalent to a pi over 6 angle, it would be 6 pi over 6. So what do I need to do to go to 7 pi over 6? I have to go a little bit farther, pi over 6 farther. I'm not going to be super accurate with how much distance that is. I just need to know that it's in quadrant 3. So we'll get to that in a second. So how do we go about from there figuring out the process? Well, again, any irrelevant pi over 6 angle is in the family of pi over 6, which means this is the reference angle right here, which is also going to be just pi over 6. So what we need is the cosine of pi over 6. Well, the pi over 6 angle, as we know from over here, is root 3 over 2, 1/2. Okay, so if we know that's the case, then we can look at this and go, the cosine of pi over 6 is always equal to the x coordinate. So we go over here and go, oh, the x coordinate is root 3 over 2, which means the cosine of pi over 6 is root 3 over 2. Okay, so once we get that, we know that the cosine of 7 pi over 6 is either going to be positive root 3 over 2 or negative root 3 over 2. How do we determine that? We immediately go to our quadrants and we go, all students take calculus and label them. So we go, well, what is our important quadrant? It's 3, where only tangent is positive, which means cosine is negative. So we take the root 3 over 2 and make it negative and get the answer to our problem. Again, you might have learned this in a different method. If you're using triangles, I wouldn't suggest it. If you're using degrees, I would not suggest that. Though both are crutches in terms of understanding trig. But if you know coordinates, like you memorize what this coordinate is and where it is, that's fine. I have no problem with that. Clearly, you're going to have to go over negative root 3 over 2 and down negative 1/2 to get to that quadrant. So if it's easier for you to pick it out that way, that's cool with me. But this is the way I show my students in my pre-calc class. Okay, so why don't we talk about, we haven't done, looks like we haven't done tangent, so we'll do tangent. And it looks like we haven't talked about any pi over 3 angles, so let's say let's do a negative this time. So let's do negative 7 pi over 3. Okay, so a lot of times there's parentheses here to make sure you're doing an evaluation. So what does that look like? All right, so if we go in the negative direction, that means that we need to go the opposite rotation, which is clockwise in this standpoint. So if we're going clockwise, we have to change our axes. We don't have to. A lot of students can do this without it, but if we go over to negative pi, which is over here, that's the same as negative 3 pi over 3. We need to go a lot farther to get to this. So what if we went all the way around to 2 pi around the circle? That's actually at negative 6 pi over 3. So it looks like we have to go even farther, another pi over 3 into quadrant 4. So what does that look like in a rotation? Well, you go like this all the way around, and then a little bit farther to there. So that's going to give us a rotation of negative 7 pi over 3. So as we said before, just like with pi over 4 and pi over 6, if you have a relevant pi over 3 rotation, then it's going to be in the pi over 3 family, and this angle here, right there, is going to be pi over 3. So that means we're dealing with a pi over 3 angle. Well, pi over 3 is the coordinate 1/2 root 3 over 2. That's where it basically is located. So what we're trying to find here is the tangent of pi over 3, which is going to be equal to, if you recall, y over x. Okay, so what do we need to do? Well, y is root 3 over 2, and x is 1/2. So if we multiply top and bottom by 2, or we could divide by a fraction, multiply by a reciprocal, either way, we're going to end up with a single value of root 3 as the tangent of pi over 3. Now note, this is not the answer. This is the tangent of the reference angle, which is a good resource, because now we can find this guy. So how do we do that? Well, again, we know where it's rotated, so all students take calculus. So this is the important quadrant here. So apparently cosine is positive in quadrant 4, but we are dealing with tangent. So the answer to this result would have been either positive root 3 or negative root 3 over 3, negative root 3, which this result tells us that it's going to be negative root 3. So that is your solution. Now note, there is no coincidence, or basically, it isn't a coincidence here. Just be careful with these negatives. So students will assume that because this is negative over here, that this has to be negative. It doesn't have anything to do with anything. It's just about the evaluation. So we get negative root 3 as a result for this particular problem, which I just noticed is number 3, not number 2. All right, so let's try a inverse trig function just to make sure all is good here. So say we did the cosecant of negative, let's do negative 11 pi over 6. All right, so what does that look like? First things first, where are we rotating? So we're rotating backwards. If we go over here, it's negative 6 pi over 6. If we go over here, it's all the way around, it's negative 12 pi over 6. So we don't want to go quite all the way around. Start here, end in here. All right, so it looks like that will be our rotation in quadrant 1. All right, so just a note here. There are many ways to do this, but literally, normally what I say to students is just convert this to sine. So what does that look like? So this is the same as 1 over the sine of a negative 11 pi over 6. All right, so all we have to do then is find the sine of a negative 11 pi over 6, and whatever we get, we can just mathematically find using reciprocal. So remember, we're dealing with pi over 6, the pi over 6 family. Why? Because this is a pi over 6 reference angle. If that's a pi over 6 family, pi over 6 is going to be root 3 over 2, 1/2. Okay, sine is always going to be the y coordinate. So we're dealing with a half right there, right? So the sine of pi over 6 is equal to a half. Therefore, the sine of negative 11 pi over 6 is either going to be positive or negative a half. Essentially, that's what we do. We're in quadrant 1. Well, in quadrant 1, all trig functions are positive, no matter what you do. Which means immediately we know we can replace 1/2 in the denominator, and 1 divided by a half is positive 2. So the result is going to be positive 2. Okay, I just want to talk about 2 other examples and then we'll move on. So let's just say, for argument's sake, we did the cosine of, let's say, pi. Okay, so what this does is changes things up a little bit. So pi is actually located on an axis, right? So if we look at our unit circle, pi is actually here at the coordinate -1, 0. Okay, that's our rotation right now. So in the positive direction of pi. So that changes things a little bit. First of all, what does that do? So this stuff here is no longer important. So actually, more importantly, it's this stuff here. Forgot I wrote that stuff on the right. So those coordinates are not important. And this is also not important because we're not actually in a quadrant, which means the only thing that we're really going to need is this here in our problem, and understanding obviously this, but that's not really a requirement. That's just something, that's logic. Most students know these coordinates. So it's just about knowing the formula. So what does that mean exactly? So all we have to know is what the formula for cosine is. Well, cosine is always equal to the x coordinate. So we make the coordinate at a pi rotation, and what is the x coordinate? It is -1. Believe it or not, we are done. So that's it in terms of what we actually use from that standpoint. Well, what if we did the tangent of, let's say, 3 pi over 2? Okay, just see what that looks like, all right? Well, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So we look at that. So basically, it's 270 degrees around. Once again, we try not to use it as a crutch. So what do we need to do again? Since we know we're on the axis, we just have to find the unit circle coordinate, which is 0, -1. So what is tangent the same as? Tangent is y over x. So y over x is going to be -1 over 0. Well, anything divided by 0 is not possible, or in other words, it's undefined. Which means if we put tangent of 3 pi over 2 in the calculator, we would get a big fat error because the answer to the problem is undefined. So just to be clear though, I want to do a side note. What if I had done the cotangent of 3 pi over 2? The cotangent of 3 pi over 2 is actually the opposite. It's x over y. It would have been 0 over -1. So that would be equal to just 0, because 0 divided by any non-zero number is 0. So these are just side notes. These are things to take note of. I purposely went through a bunch of problems here for those of you who are not clear with trig, but this is essentially the first part of the lesson. There's another part that we have to get to right now. So what about trig equations? So not only are we going to have to evaluate trig functions, but we're also going to have to solve trig equations. And this is the last stop in my trig review, because these are the two main components of what you're going to need to know for Calc 1. So what about solving trig equations? Well, it's all about doing examples. There's not really any other way to do it. So let's just say, let me restart the numbering here. We'll do this in green. So let's do solving, we'll do solving trig equations. All right, so let's just say I said, when is the cosine of x equal to 1/2? Okay, so this is known as a trig equation because you have a missing variable within a trig function that is equal to some value. Notice that we don't have anything else on the left side but that specific trig function in terms of this. It is possible that this problem could be given to you like this. Okay, you would not want to solve it like that. You would want to divide both sides by 2 and get this, which is what we have now. So just a side note, but that is a possibility for a way this could be given to you. But most of the time, you're just going to be solving with something where you have a trig function isolated with a variable on one side. That's how you solve it. So let's think about this for a second. When I'm actually doing this process here, it is essentially the opposite of this process here. So normally I'm asked for the cosine of some radian measure, and I want to find the actual ratio I get as a result. Here, I'm given the ratio right here, and I want to find the radian measure. So it is the complete opposite of what we actually did just now. So how do you do that exactly? Well, what you really do is you do the opposite direction of what you did up here. So what was the last thing we did in these problems? We did all students take calculus. So that's the first thing we're going to do. So all students take calculus. So look at our answer for evaluating cosine is positive. So this angle can only exist where cosine is positive. So which two quadrants does this occur in? Well, we know that this is always positive, so we have to find the C. The C is here, which means right now these two quadrants have been eliminated as possible solutions, locations for this problem. So we now know that our solutions are going to be in quadrant 1 and quadrant 4. So there's going to be two solutions. Fantastic. Okay, so what's next? Well, what did we do prior to this? We looked at these formulas up here. We talked about, well, what do we need? We have a coordinate here, right? And we have a formula for sine, cosine, tangent, and the reciprocal function. So we're going to now use those in unison to figure this out. So what does that mean? Well, why don't I, just for argument's sake, why don't I, even though it wouldn't matter, I'm going to make this theta so it doesn't get confusing with the variables. So let's just say that, make these theta too. Let's just say that we're looking at this and we're saying, well, what is cosine? Cosine is always the x coordinate, right? It's always the x coordinate. And when is the x coordinate going to be 1/2? So we go over here and say, oh, well, the x coordinate out of these three values, the x coordinate is 1/2 whenever we have pi over 3. So that means that in the first quadrant, the solution is pi over 3. But we're also picking the members of the pi over 3 families that exist in each one of these quadrants. So we need the pi over 3 family member that exists in quadrant 4. So what is that? Well, this is 3 pi over 3, and this is 6 pi over 3. So what's going to be 1 back from 6 pi over 3? 5 pi over 3. So what is the solution? Theta is going to be pi over 3 for my first quadrant solution, and 5 pi over 3 for my second or fourth quadrant solution. So this would be the solution to the problem. Now, just as a side note, this is not always easy for students, and you could probably see why. Students will often be able to do the evaluation okay, but then anytime you ask anybody to work backwards, it does provide a little bit of struggle. So what's the easiest way to, when you're done, to make sure you're right? Then just do this process for each one of these answers. So in other words, plug them in the theta and make sure you get a positive 1/2 for each one of them. This is a great way to check your work, basically, when you're doing these problems. Okay, let's try another one. Let's say I asked you for, I said the tangent of theta is equal to -1. Okay, so this is inherently a more difficult problem. Why? Well, before we get anywhere, let's first do our quadrants. All right, so we're looking for when the tangent is negative. Well, the tangent is positive always in quadrant 1, and it's positive in quadrant 3, which means we know that these two quadrants are going to be where our solutions fall whenever we find the proper radian family. Okay, that's going to be the key. So we already located our quadrants of importance. So what do we do next? So tangent is equivalent to the formula y over x, which is again here. So when we're looking for when we divide y over x and get essentially -1 or +1, it doesn't matter at this point. So we go, all right, well, the only way you can divide two things and get 1 or -1 is if they're the same value or the opposite. So we look up here and go, well, which one of these coordinates occurs when they're the same value? Well, clearly pi over 4. So that means we are clearly dealing with the pi over 4 family. And that is all we care about. Because now we need to find the pi over 4 family in quadrant 2 and 4. So how do we do that? Well, again, this is 4 pi over 4 here, and this is 8 pi over 4 here. So what is this going to be? Well, we have to go back to 3 pi over 4 to get our first solution. And over here, we have to go back from 8 pi over 4 to get the other one, which is 7 pi over 4. So the tangent of theta equal to -1 solves to theta equal 3 pi over 4 and 7 pi over 4. These are the two solutions to our problem. So you can see that was more complicated because the formula wasn't as easy, but that is essentially how you find those values. Okay, so let's try just one more, and then we'll end the trig review. So let's just suppose I asked you for something. So let's say we said the sine squared of theta is equal to 3/4. Okay, so this looks weird right off the bat, right? So now we have a squared going on in here, and we have the 3/4, which doesn't look like any of our special results that are going on over here, right? Doesn't look like any of them. But the key is that when you solve a trig equation, you always want to have a single power sine or cosine or trig function in general. So right now, just like any other problem that's squared, we can take the square root of both sides. So when we do that, we're going to get just a single sine theta over here, and we're going to get the square root of 3/4 over here. But there's one small thing that students always forget. Whenever you, let's say, if you said x squared as an aside, if you said x squared is equal to 9, what would you do? You would take the square root of both sides and get x is equal to plus or minus 3, would you not? So you got to remember the plus or minus when doing this, or you're going to run into a lot of problems. So again, let's repeat this. We can definitely simplify this. This is the same as √3 over √4, which is the same as √3 over, hey, it's √3 over 2. Look at that. So we actually have a good result here. So before we do anything, let's talk about our evaluation here. Let's talk about all students take calculus. So we're looking for when sine is positive, first of all. Well, that occurs here and here. But according to this, we're also looking for when it's negative. But that occurs here and here, which means, holy moly, we're going to get 4 solutions to our problem. Which means we need the answer in every quadrant. So how do we do that? Well, we're looking for when sine, which is y, we're looking for when the y is √3 over 2. So we go back to our coordinates and we go, the y is √3 over 2 for pi over 3, which means we need the coordinates values, the radian values at each quadrant of pi over 3. So the first one we know obviously is pi over 3. So remember, this is 3 pi over 3 here, and this is 6 pi over 3 here. So how do we find them? Well, if we went over here, we have to go a pi over 3 back to 2 pi over 3. So we already got one of them. Now two of them. Here we have to go this way to a pi over 3 to 4 pi over 3. And here we have to go back 1 to 5 pi over 3. Which means the solutions to our problem are all 4 of these angles. And if you plug them back into here, we would get the same thing. A side note, by the way, sine squared theta is the same as sine theta squared. So when you're evaluating, you would take these values and you would plug them in here and then find the evaluation and square it. So that's sort of a side note. So that is our, as in a nutshell, that is our trig review. You need to know everything on this page. If you don't, get studying, because before, you're going to be completely basically flattened by work in the beginning here with lessons and just the whole 6-week semester that we have here. So make sure that you can do trig evaluation, make sure that you can solve equations, because it will come up, and I'm not going to be shy about doing it on exams either. So be ready for it. Start now if you need to in terms of reviewing that stuff.